It is just after the hour. Thanks everyone for joining another one of our webinars through the Stender School. My name's Joe. I'm an admissions counselor in the Stender School. Just wanted to welcome you and kick things off here. We will record this, so within the next week or so, we'll send you a follow-up. It'll have the YouTube link to this presentation, a certificate of attendance if you need that, and then just some info about programs at the Stender School if you or anyone are looking into pursuing a graduate degree or certificate this summer or fall. We do have an AI certificate coming out that Brandon is working on right now, so we'll have some more news on that this summer. It's an extension of our data analytics program. So cool stuff if you're looking into exploring some materials with AI this year. So we'll be in touch with that, and then just send us any questions that come up subsequently. But with that, I'll turn it over to our headliner, Tom Gibbons.
All right, thanks, Joe. So let's see if I can get these slides advancing. So I'm Tom Gibbons. I teach at the College of St. Scholastica here. I've got a background in artificial intelligence, although it was quite a while ago. But I still continue to teach and work in artificial intelligence regularly. In particular, I teach two classes at the College of St. Scholastica, which serve kind of as a basis for this webinar. And I'll be pulling material from those classes for this webinar. One is an undergraduate class, which is just machine learning, which is a pretty wide survey of machine learning, and it's for a wide variety of students. The other one is in our Masters of Applied Data Analytics program. It's just applications of machine learning. And that is part of a larger program, focused on data analytics, machine learning, and AI stuff. In most of these models, or in classes, we'll cover a number of things. Traditional machine learning models. We'll look at neural network models and understand all those, and then from there we build up to attention and what are called transformer models, and from there we get large language models. Today, a lot of people, when they think about AI and stuff, they think about large language models, and then we'll focus largely on those today. But we have to understand some of these basics before we get there. So that's part of what we'll be doing today, is just kind of looking at some of these other models and some other ideas and what you need to know to kind of understand and use large language models as we work through things. So let's just talk about the large language models in general. And they almost all use this structure called transformer architecture. And it's really a cool architecture, and it'd be fun just to spend week going over it, which we often do in class, but we won't today, of course. But just a couple highlights of stuff that is helpful to understand if you're going to be working with large language models. The model works that we have inputs and these are generally your prompt text here. It can be other things, multimodal models, we do other things, but we send a sequence of inputs into this model. Each of these inputs is then encoded some sort of what we call an embedding. We take every word and map it into this, big list of numbers, trying to encode each word, and then that encoding kind of tries to represent how words relate to each other. So similar words will have similar embeddings. Related words will kind of have related embeddings, and some neat things you can do with those. We'll need to know that later on, because when some of our work, when we're working with documents, we'll have to embed the documents in a similar way. And there's a number of different embeddings companies use for this. Now, once we have these embedded, we do some encoding to organize the position of them, with text with a lot of things, the order is important. So when you say words in a certain order, we want to make sure we maintain that. So we have a way of encoding them positionally. And then we feed into this big neural network called an encoder-decoder system. And this is just a summary of this, but one of the things it does is it has these attention mechanisms. And to tell you the truth, you probably don't need to know a whole lot of how encoder, decoder, and attention stuff works at this point. So I'm not going to worry about that. It's cool stuff, but it's not stuff you necessarily need to know when using these models. But just so you know that what we're getting as an output is a prediction of the next word. And as we predict next words, we take those words we predict and we feed that back into the network. So you also see it as input in the bottom, the outputs, the previous outputs. So these models are trained to predict the next word in a sentence. And so we give it a prompt and then it starts producing words, outputting words, and it keeps looking at the prompt and then the words it's produced so far, and it predicts one word at a time as we go. So that's kind of what we're working on here. Let me look a little bit at what this is made up. So these boxes here, these like feed forward and multi-headed attention and other boxes here, those are really neural network architectures. And just a quick summary, I don't know if you know what a neural network is, but all it is little computational nodes or units that are connected together. And they're connected together with these weights. And they do computations via these weights, and it's neat algorithms to do. So, and we generally train these by giving it an input, having that input flow through the network to an output, and then from the output calculating looking at what the output should do, and then changing the weights so that the actual output of the network matches more closely the output of the network here. And so these weights all have to change as we learn. And so we need lots of data to train these networks. And so we can often count how many weights there are to change, and we call that the number of parameters in a network here. So the more parameters, the more weights we need to change, more connections between all these little nodes in the network, the more training data we need and training time we need. And these networks can get very large here. So for example, GPT-2 had almost 2 billion parameters, 2 billion weights that had to be trained. GPT-3 had 170 billion weights or parameters here. GPT-4 is rumored to need about or have about 1.7 trillion parameters. And there's lots of work today to make networks with different size of a number of parameters, and can we get a large language model that works well without a trillion parameters for this. So often we'll talk about the size of these networks that we're working on, and the number, so that'll often talk about the parameters for this. Now, this isn't so important when you are just working on a cloud-based system like ChatGPT, but if you're going to try to run a local system on your local network, on a local computer, then it's important to, you can't run a huge model on a local machine generally. So we'll see reference to the number or the size of these networks when we look at taking one of these models and running it within our company or within our organization. So another size thing you may see sometimes is the size of the inputs for this. So when we're feeding this data in, so if we look back at this network, we're sending this input one at a time into here. How much input does the network remember here? And generally, we've been trying to expand this. Originally, GPT-2 would remember the last 500 tokens. So again, I'll use the term word and token interchangeably. They're about the same here. So a token is just a way of encoding text, and it approximates us about every word is about a token here. So 500 tokens is about 2 pages. GPT-3 could remember 2,000 tokens, about 8 pages. And look back, GPT-4 is about 8,000 tokens. And so that'll come into play later on when we're trying to feed a document into it. If we want it to look at a whole document and it's bigger than 8 pages, we probably going to run into problems here. Now, some of the models now are really pushing this up where we can have lots of tokens. And so there's questions about that, how efficient and that sort of stuff. So those are the 2 kind of sizes we need to kind of worry about when we're talking about what kind of large language model we're going to be running in our system. Okay. Next thing we need to kind of talk about is proprietary versus open source models. I would guess, I assume most of you have some experience with a large language model, like maybe you've used ChatGPT or Google Gemini or Microsoft Copilot, and you've typed in a prompt or question and gotten the output back for things. So these are proprietary models. They're running, they're owned and controlled and trained by companies like Google or OpenAI. They have a huge support system. They're very expensive to run and maintain. They took a lot of training data to be trained and a lot of expense to train these, both in getting data, both in electricity, but also in just like humans. A lot of these have a lot of human reinforcement learning and stuff like that, where humans have looked at the output of these models and rated it so that the model could get better at this model. And so there are different, these companies are trying to make money off of this or, stay profitable. So there are different free and free versions of this stuff. One of the problems we have with these models is that often you can't, you have to send your data off site to these companies, and you have to trust these companies with that data. And a lot of times, especially with the free version of this software, the data that you send will be used for future training or incorporated in their training database and stuff like that. And so, of course, you don't want to send proprietary information. You don't want to take someone's health record, medical record, and send it to ChatGPT and ask for a summary of it because regulations, certainly privacy concerns prevent you from doing that. Now there's work on these companies. If you pay a higher fee, you can get you can get levels of protection on your data, and so we're seeing that as a possibility now. Now, if you want to do these sort of, what we're going to talk about today with your own data, often you're looking at running what might be called open source models. But a lot of them aren't technically open source. They're models where you have access to them, but they might not have the full open source license. But they are what we call local models. So local models are models you can download. You can download the whole model, all the weights, all the connections, all this stuff. It's all pre-trained, and then you can run it on your local machine there. It's challenging to run this on a laptop, but you can certainly run it on a larger machine in an organization as you go. Some example, of this, Llama, Mixtral, and Gemma are well-known examples of kind of these open source local models here. If you want to look at more models, I suggest a company called Hugging Face. They have really grown into the hub of models. So if you go to Hugging Face, just Google Hugging Face and click on their models link, they have hundreds of different models and they rate them, and they have models for all sorts of things, large language, image generation, sound, comprehension, voice generation, all that sort of stuff. And then you can download these models and run them on your areas. Now, there's a lot of software to do this. A lot of it, again, this is all so new. A lot of this is still, I would say, not that consumer friendly in that you often have to type in commands on a command line, and a lot of tutorials are telling you open up a command line, type prompts, and if you're not in the computer field, a lot of times that's just a little bit too low level for you to do. We are seeing more better interfaces to these models. So one, if you are just interested in trying these out, there's a program called GPT for All, and you can download an installer for Windows or Mac or whatever, and then you can just install it and then select the model, and there's a nice user interface for setting up and using your own local model. You need a pretty good computer, particularly one with lots of memory. There are a lot of RAM, at least 16 gig of RAM for this to work. So, all right. I'm wondering, I'm getting into this, I'm wondering about questions. I'm not seeing my chat up here.
I've been keeping an eye on that. None
Okay.
so far, but if the audience does have questions, feel free to put them in that chat box.
Yeah. So why don't you see as we go along, if you want. So what we're going to look at next is how we can adapt and use these large language models for things. So I'm going to look at 5 different levels of this here. At the kind of top level, the easiest level is just prompt engineering, and you've probably seen this in the news and that sort of stuff. And you probably, I think we all, if we're using large language models, do this to some extent. How do you write a good prompt, and what do you do to that? And that's just the basics. And again, there's lots of resources on prompt engineering, so I'm not really going to talk about using one-shot or multi-shot prompts, or stating who you are or what you expect or what role you want. There's lots of resources out there for that. So I'm going to try to move to the next level, where we start kind of looking at using these large language models as AI agents. And we're going to look at 2 different ways of doing this. One is called LangChain, and that's just stringing prompts together. The other one is Crew AI, and that is kind of try to develop agents for this. Then we're going to look at retrieval augmented generation, where we can bring in our own documents, our company documents into this, and ask these systems questions, and to use our own documents to answer questions. So we won't get into some of the more complex stuff. Prompt tuning or fine tuning, that's where you are taking one of these large language models and doing additional training on it. And so there's certainly some reasons for doing that sometimes, but again, that's higher level, or more, I guess, lower level stuff where you're actually needing data. You need to be running systems to retrain these models and stuff. So we won't be doing that. So let's start with this first step. Looking at LangChain and putting prompts together for this. So I think of this as coordinating or orchestrating prompts. We're going to use your favorite LLM out there, and so we'll work with just about any LLM. We'll create templates for prompts, and then we'll use the output of one prompt as the input to another prompt. And again, you might do this manually already. I don't know if you do this, but I certainly do. If I'm just prompting, I'll type something in, get some output, and sometimes I just highlight that output, paste it in the next prompt, and say something, can you do something with that? And I might get something, paste that into the prompt again, and ask them to refine that, or just ask them to redo the previous structure. So that's kind of what we're looking at. Now, there are different options out there. We're going to look at something called LangChain for this. So LangChain is an open source framework for working with these LLMs here. It is generally you have to program it in Python or some environment like that. And so in the class I teach, we use Python to do some simple interfaces with these LLMs. Here, what we generally do is define a template for a prompt. And a template for a prompt, I always think of as kind of like a Mad Lib. And I don't know if everyone knows what Mad Libs are, but when I was growing up, Mad Libs we played as a game where you say, give me a color and give me an action verb and give me stuff. And then people would fill in those blanks and then you'd read out a story based on those filled in values. And that's, again, what we're looking at, this prompt template. In this example, we say, we're going to make up a story. So we're going to make up a story about A, and then we're going to fill in an animal who likes to wear, and we're going to say a piece of clothing there. So we fill that in. We set up that prompt template, and at the bottom we say, okay, now generate a story, or in this case, we tell the chain to predict the next words here. But we're going to use, for animal, we're going to use tiger, and for clothing, we're going to use tie here. So it should make a fun story. Well, I don't know if it's a fun story. It should make a story about a tiger wearing a tie for this. So that's how these prompt templates work here. And you can set them up for lots of different things. But having these prompt templates and these, variables we can put in them allows us to tie these together. So how do we tie this together? So the output here is we store the result in my story for this. And so we're going to use that in our next prompt. So here's a follow-up prompt. Modify the following story so it includes a product placement in significant places of the story, and then we have the story. So we're taking the story that we generated. So when we we tell this to do a prediction, we say the story you want to use is my story, which is the story from this is the previous thing where we created my story. The story is the animal about the tiger and wearing a tie. So that's in this my story variable. And then we're going to predict this, and we're going to do product placement. So again, we can put your favorite product placement, and mine's obviously ice cream. So we're going to place product placement of ice cream throughout this story. So it'll rewrite the story and now add this product placement throughout this stuff. And again, that's how you can chain these stories. You can take the output of one, and then you can create these chains so they're all set up. And so then at the beginning, you can just fill in a couple blanks, and it will run through this whole chain of prompts and generate what you want for this. I'm going to show you quickly what we're doing here. In class, we use a environment called Google Colabs or Python notebooks here. And I have links in them in this presentation for this. So if you want to try these out, you can, but we have the code here. So we do things, connect up to a language model here. We then have a story and set this up and run. So like here's our actual sample. Make up a children's story about a tiger, and so it's making once upon a time in a lush jungle filled with color flowers there lived a young tiger named Timmy. It talks about that, and then we say modify it, and then so now we have Timmy eating ice cream in the next story for this. So in class, we work through this example, which is out there, where we take an image. So we take one of the St. Scholastica images. And so from that image, we have one model caption that and create a caption describing what's happening in this image. We then take that caption and ask another large language model to generate text. So we could ask ChatGPT or Gemini to generate a story about that. And then once we have that text story, we feed that to a third model to speak it, to generate the audio. So create a voice and generate that story. So again, we're basically starting from a picture and we end up with a story that's spoken out, that's inspired by that picture for that. So again, if you want to look at these notebooks, there are some QR codes on some of these slides, so you're free to grab those and do that, or you can let Eric know, and Eric can send out this link also for this. Okay, so that's the simplest way, just chaining prompts together for things. Let's try to actually make some AI agents. So the next thing we're going to look at is at Crew AI here. Now, it's always a struggle to figure out which of the software to teach students and which of the software to show you. So there are lots of different options out here. Like in this framework, I would say there's Crew AI, and Microsoft has something called AutoGen, which is similar. It's somewhere kind of in between LangChain and Crew AI as far as functionality goes. And there are other ones. Those are probably the two most well-known ones, but there are lots of people creating this sort of environment out there. In fact, just last week, or actually earlier this week, Google just released their whole AI agent areas. With these AI agents, so like, there's a whole area now with Google to do that. So we are going to look at this and again, program this in Python, simple Python, but there are lots of environments now, that will let you do some of this with more of a user interface for this. So what is Crew AI? Crew AI is an environment where we're going to set up agents, we're going to set up tools, we're going to set up tasks, and we're going to bring these all together as a crew, and it will work on that. So Brandon was asking, can you interact with these LLMs and do you need money and funding for that or what? Anyone can interact with these LLMs, and next time I pull up a notebook, we'll talk a little bit about how to do that. I think how to get an API key to do that. So okay, so here's our Crew API. Let's start. We'll just go through all three of these things. An agent, if you have an agent, you need to give it a name, give it a role, a backstory. Basically, you're making these characters here, and then it has to have a goal, what it's going to do for things. So here's an agent example in Python. Its role is a research specialist. Its goal is to conduct research on people and companies, and its backstory is here. So we just kind of define what it can do. We also define what language model it's going to be using for this. Next, we define tools, and these are access to things besides what the large language model knows or has been trained on. So maybe there'll be website search tools or PDF search tools. Maybe there's files you need to read, YouTube you need to search. So there's a number of tools that are predefined, and you can kind of define your own tools for this sort of stuff to get access to this. And then the last thing you need is you need tasks for this. So tasks just has a name, a role, a backstory, and a goal. So here's it. So here's our description. I think I didn't update that last slide. So actually, tasks should have a description and expected output. So here's our description here. Conduct a comprehensive research on individuals, gather information about these participants here, and the expected output, what you want this to produce for this. And then you list what agents should be doing this task. So you create your agents and then you give the agents tasks. So here we're saying the research agent will be the agent that's in charge of the research task here. And then we finally make a crew here. There are two main ways to organize crews. One is sequential, and there we just list a set of tasks and they go through the tasks in order. The other one is hierarchical, where you can assign a manager agent, and then the manager agent will look through that. It will have a task and will work with the other assign tasks to the other agents in your crew as you go. But the default is the sequential one, and that's where we do this example as a sequential, just a series of tasks we want to do here. So again, we do a notebook here in class where we're going to do this prep. And Brandon was asking, how do you get access to these LLMs? And so one thing I just will mention briefly is that to tie in our code or any sort of our environments to certain LLMs, you need a key, and this is called an API key for this. And you need to tie these keys together. So here's an API key, and when we define our link to like ChatGPT, or we can tie into OpenAI's models, or Hugging Face has models, or Google has models. So all of these will have different keys, and we can tie into these keys in different ways. Once we have tied into these LLMs, we can define our agents here. I'm going to go up here and go to this one. Okay. Where again, we can define our agents and what they're going to do. So this task actually does this. So we have 4 agents, and we're going to prep for a meeting with an employer. And we give our crew a list of people who are going to be at the meeting, their email addresses, a description of what the meeting is and what the outcome of the meeting will be, and then the agent or the crew will look through the emails, research, figure out what companies the email addresses are from, research those companies, research trends on those companies, and then create a briefing for us before we go to this meeting. And so we've just breaking it down in these tasks. Research specialists, basically all this, I mean, it's a fancy word for someone who looks at the email addresses and figure out what companies they're going and tracks down those companies. We then send that to an industry analyst agent, which looks at these companies and tries to figure out what industries they are and does some Google searches on, or web searches on what are the trends in these industries here. We then feed that the results of those 2 agents to our next task, which is a strategy agent, which tries to kind of plan out a meeting strategy. All this is fed, all the results of all 3 of these agents is fed into our briefing agent and task, which is supposed to create a briefing for this meeting to help us prepare for this stuff. And so again, we're just tying these all together into this one output or one kind of task. And we just kick off our crew and it runs, unlike, often when I type a prompt, maybe in ChatGPT, it will respond relatively fast. Here, this will take a while. I mean, these agents have to be searching the internet, tracking down stuff, feeding information back and forth here. So this might take 5 or 10 minutes to run and generate our results. Because again, these different activities are running and feeding information from one to the other. And we have multiple queries to our one or more of our LLMs to do this. In the example in this notebook, all this feeds into a single LLM. Or we use just one LLM, but you could use multiple ones to do this stuff. So that's how Crew AI kind of works. Now, both of these systems are not changing the LLMs. We are just kind of doing more complicated prompts and organizing our prompts for this to create these AI agents. So like with LangChain, we just set up these prompt templates. We took the output from one, fed it in or modified it and fed it into another one. And you can do complicated kind of systems of that. Same with this. All this is Crew AI is just a way of creating these complex prompts. And you can kind of imagine people why they created these tools. They probably started just writing. You can do this all on your own. You can just write a prompt and you can say, okay, now you are this sort of you're a market researcher and you're going to research this, do a market research on this product and give it a product name and produce a marketing report and have it generate that. And then you can take that and you can just manually feed that in and say, okay, now you are a research specialist. You're going to research trends in this market. So take this market analysis and research trends in this. And then you could say, okay, now I need a social media post on this. So write an article based on the trends. And you can write, say now you're going to play this role, and you can give the LM multiple roles and try to manually tie your prompts together. But again, if you do that again and again, and you have the same sort of thing you do again and again, it's helpful to define these systems so that you can just have a crew out there and they say, okay, I need a social media post on this topic. You can just give it to your crew of prompts, of agents, and the agents will go out there, research that topic, look at trends in that topic, create a social media posting on it. You can even have them go out and, create a video or create audio from that for you. So that's the idea, is just kind of, we're not changing the LLMs. So again, if we're really going to, low level change the LLMs, that's way down here in 5, where we're actually changing LLMs. We're doing much higher stuff. Okay, let's look at the last thing here, and that's retrieval augmented generation for this. I'm just going to pull some quotes from some sources out there. And so one of the things I try to rely on is, is this just a new one-off thing, or is this trend, have some traction? And when I start seeing the big companies devote websites or web pages to these trends or these technologies, I say this is looking important here. So like here, IBM has a whole, a couple pages on their website on retrieval augmented generation, talks about it as a framework. And again, they're talking about external sources of knowledge here, improving quality responses. NVIDIA, the big hardware company, again, is pushing this. They have this nice diagram. So let me just walk through this diagram real quick. In a traditional LLM, you have a new question, and it looks at your chat history, and it just generates an answer, and there's nothing in between. We're adding all this stuff in between here. So we're taking your new question and then we're feeding it to a store of all of our company's documents, or whatever documents we want to put in this vector store, we'll call it. And we're pulling out the related documents. And then we're feeding that to the LLM. So we're feeding the original prompt or question plus the relative documents. And saying, okay, looking at these documents, give me an answer for this. So again, that's NVIDIA's point on this. Let's look. Oracle, again, is also pushing this, argues for, some of the reasons why you might want to use RAG. It gives you access to, allows you to freshen up the data. So again, sometimes when you're going to ChatGPT, it'll say, oh, I don't have any knowledge of anything from 2021 on, or something like that. So you can give it new documents. You can update those documents. They can be more contextual to your question or your business. You can have your own corporate documents. You can, your own records, your own data, whatever you have is part of this here. And then because the LLM is looking at your own documents, it can cite and source those documents. And you can say, according to this document at this point, and here's a quote from it, this is what it says for this. And it certainly reduces errors that we see here. So, and again, AWS, Amazon's AWS, if you just Google AWS RAG example notebooks, they have a number of notebook examples similar to what I use that also use LangChain as kind of the underlying focus here.
There is a question that's come in wondering, is there a feedback loop where LLMs learn from previous interactions?
Generally not. It depends on what you mean by learn. So sometimes when we say learn, we just mean, are we changing the underlying weights or parameters? And that's really hard to do, so we don't do that very often. Another way we can kind of learn is we can incorporate some of that text or some of that, feedback or information into future prompts. And so we can send that prompt in. And so RAG is like a way of doing that. So if you could create or save some of this stuff in documents and then give the LLM access to these documents, then they could learn from previous prompts and responses. See if that answered it. Well, let's just look at RAG a little bit more here. So prep, we're going to want to encode our some documents in here. So we have to identify what documents do we want the LLM to know and use. What data, is it tables? Is it text documents? Is it marketing materials? Is it photos? Is it, videos? What is it? And in my examples, we're still just using text stuff. So we extract the text from these documents. We then have to split the documents into chunks. We embed the documents. And this is important. We have to use the same embeddings as the LLM does. So if you remember, the first stage of LLM is always take the text and embed it. And so we have to use that. And so all the LLMs will have some tools out there that you can use the same embeddings they use to embed your documents. And actually, these are document chunks. And we store them in a database. Now, this is not what we would call an SQL database. It's a special kind of database called a vector database, where the embeddings act as keys so we can do similarity searches on this here. There are different vector databases. In our examples in class, we use one called Pinecone because there's a nice free level that we can set up and use there. So basically, we're taking our documents and breaking them in chunks and putting those chunks into a vector database. Then we're ready to take a query. The query is always embedded. We do a similarity search on the database, and then we pull those. Let me look at a picture of this, and maybe that'll help. So so here's our documents here. We're going to break it into chunks, create embeddings, put that in a vector store. We're then going to take a prompt. We're going to embed that, do a similarity search on this, and we're going to get out find the matching document chunks. So here's our matching chunks, and then we're going to send those document chunks with our original prompt to an LLM to answer a question. Now, let's try a real example. So here's our real example. We're at the College of St. Scholastica. All of our students regularly read our student handbook. Right. Well, we take our student handbook and we're going to use that. We're going to break it in chunks, embed it, and we're going to put it into a Pinecone vector store. So I have it out there. I've actually created a Pinecone vector store with like a number of the student-facing documents. Our catalog, our student handbook, the student employee handbook, all that stuff is going into this Pinecone vector store for students. Now, the student can ask a question here, like how many, what courses that are required for a history major, or how many credits are in a history minor, or something like that. We will embed that prompt, do a similarity search on this vector database. It will pull out the corresponding chunks out of the course catalog or the the student handbook or whatever, and it'll feed that along with the prompt into a large language model. And you might wonder, how are we combining that into one prompt? And then you think back, oh, when we did LangChain, we could set up these prompt templates. The prompt templates could do that for us. We could take our prompt and some chunks of data, and we can do that for this. We can also, in this prompt, say, look through these documents to answer this question, and if you can't find the answer in these documents, say, I don't know. Or the answer does not seem to be in the documents here. So one thing we'll get frequently from these LLMs is just I don't know answers, which is much better than making up answers, which LLMs often do. If you just ask them a question and they don't know the answer, they'll just make it up. So that's this retrieval augmented generation stuff. Let me just jump to that. So again, here's what we do for this. Again, this is an example. There's some modified from a tutorial online, but we walk through and we do the same thing. We break our chunks, our data up into chunks. We embed the chunks here, and we ask questions. We store these in a vector store, and we work through this stuff. And there's different examples we do here, but in this example, we can just ask it questions. So here it has the student handbook, but not the course catalog. And so here I'm asking what courses are required for a history major. That's not in the that's in the course catalog, but not in the student handbook. And in this example, we're just doing the student handbook. And so it is actually saying, I don't know, because the prompt is set up to say, I don't know if you can't find the examples here. And here's an example where we're asking, can students drink alcohol in their dorm rooms? And again, it is looking at this. Now, here I didn't have it actually cite this, but it is possible to cite the sections, have it cite the sections of the student handbook where this is at, but it will try to summarize this. And it tends to get these more accurate than when you are just working with an LLM directly. I mean, a couple things is that, yes, an LLM probably has, ChatGPT's probably looked and seen the College of Science Classic Student Handbook because it's on the internet, and I don't know how it's gone on and what it's trained on. But it is looked at so much stuff, it's not going to remember that one document often in that one place. So if you just ask an LLM if students at the College of St. Scots can drink in their dorm rooms, it wouldn't know. But if we point it to this local data store and ask that same question and say, use the data from this, then it can give us a much better result for this. So I don't know if anyone's using this sort of RAG system. I'd be really interested to know if, from talking to some people and reading online, it seems like a very popular model for using. And I could see the benefit. I mean, in class, we were able to quickly set this whole St. Scholastica RAG system up so students can query it and get new stuff. And what's nice about that is that, next year we'll have a new catalog. We can just go to this system, drop in the new catalog, take out the old catalog, and update our, create a new vector store, and then everything will be working fine with new data for this. So I'm going to just wrap up with some questions or discussions at this point. So feel free to use chat, or if you want to just unmute and ask me a question, that'd be great. So. One of the challenges I always think of these webinars is I just don't know where everyone's coming from. That's why I miss, my classes. I know my students generally, and I know what level of knowledge they have and what they need. And I always get kind of freaked out at these webinars. And so I'd like to hear from you. How are you using anything? Did you find this useful? Do you have any questions on this?
There is another question that I see here. Then after that, obviously, anyone else. But the question, how much time would it take to create a small scale solution to use as a proof of concept for an organization? Is it a significant amount of time, or is it reasonable to create something, say, within a week?
I think it certainly, I guess it depends on what scale you're doing in, but we use these RAG systems to do these things. And so I have my students go through this example in a week where again, they take some documents, we don't actually do Pinecone because that requires them to create an API key and stuff like that. So I create that. But again, my setup time is not very long. So you can, I think within a day, again, it's going to take you a couple days to read up and learn about these things, but actually setting this all up, I set up this example in a couple hours working on this. And again, here we're not using a local LLM, we're using one of the cloud-based LLMs. I don't know if we're using, and again, but if you're using a local LLM, I would, certainly a couple more days to set that up and interface that with this. Other questions?
Well, I'm not seeing any come in through the chat either. Okay, one more here. Question, is it possible to combine a local LLM with one of the publicly available LLMs, such as ChatGPT or Copilot?
Yeah, it's certainly able to combine those two, but you're probably going to want to use a system like LangChain. And again, LangChain is the underlying technology for this RAG system we use often too. But with those, you can define LLMs. In my examples, we just use one LLM, but again, you're just creating a variable or a name for that. And then when you use that, so like with Crew AI, you can have different agents use different LLMs. So when you define an agent, you say, what LLM does that agent use? So even, with LangChain or Crew AI, you can define multiple different agents, and one can be local and one could be out there, a proprietary LLM, and you can go back and forth. If you look at the code for this, when we define these, let's say we want to do a local LLM, we might set this up so we are doing that here. And I have another LLM, and I can, right now I'm using the same name for both of them. So for one of these, I could have this called like, oops, there. Local LLM, and another one could be just, remote LLM. And then in my work, whenever I want to use one, I could use one, and then whenever I want to use another, I can use another. And again, I haven't used that many of the non-coding tools for that, but I think they are allowing that also.
And if you do combine those two, is there a risk that you might expose proprietary information?
Yeah, I think it depends on how you structure it and what you allow them to share with each other for this. Um, and so, for example, with Crew AI or LangChain, you can always kind of determine which way the information is flowing there. So you could send certain prompts to the proprietary LLM and get data back, and then send that to your local LLM mixing with your company data. Uh, but yeah, again, you'd have to be careful if you are prompting or using your local data, your local LLM with which has access to your local documents for this, and from there you're sending the results of those prompts to a proprietary LLM. You don't necessarily know what's encoded in what's in that results, and so as long as you keep the information flow kind of, I would say, in the right direction, then there's not a problem with that. I've been trying to use tools here that are free, and again, for most of our students, the only restriction I run into is that to get an API key from OpenAI, you need a paid membership for that. But other than that, all the rest of these tools have a free version that you can try out as you're learning and developing these systems.
Final question as we're wrapping up, I think. Someone is interested in the technology on the wall behind you, Tom. What have you got back there?
Uh, I'm old, and so I like old technology. So that's my Tetris wall. So it's all technology that is out of date here. It makes me remember the good old days where we had hard drives and floppy drives and cell phones the size of bricks there, and gaming consoles where we had cartridges that went in and out and that sort of stuff. So I just like to collect that, and the students like to see that old stuff too. Well, the students like to pretend they like that old stuff to make me happy.
Well, I think that's probably a good place to leave it. Thanks for presenting here, Tom. And for the folks who are attending, we will get opportunity for you to review the recording and request a certificate of attendance. And make sure you check our professional development page for other webinars coming up in the future.